folks at Banggood.com have sent me a Class A vacuum tube headphone amplifier kit. So there's the bag of parts. We're going to assemble that in this video. Now this one here does not come with a manual, so I'm going to have to work off of the layout on the board. So here's the official unbagging. Comes with a circuit board and a bag full of parts, and I'm guessing that this is going to be the vacuum tubes. Which it is. Just looking to see whether they looks like the getters are okay. I don't know about that one. This one here looks okay. Getter looks good on that one, but this one here, I guess it's okay. The getter should be in the side here. Looks like the getter's on the side of the tube, and one in the top. Okay, so we have a bag full of parts and a little circuit board here, and no instructions to put this thing together, other than what is labeled on the board itself. Let's get building. Now, unlike other kits where there's always been an instruction manual, at least this one here they label the values of the resistor on the board here, as you can see, and it doesn't label capacitors, although I'm sure that this is CD1, CD5, CD9, CD2. There's 4 of them, and in here there's 4 330 microfarad 35 volt electrolytics, so I'm sure that those are those 4. And then there's 2 other electrolytics here, 50 volt 47 microfarad. I'm sure that that's CD11 and CD12. It's kind of a process of elimination. These 2 1.5 microfarad 100 volt caps, I'm sure going to go over, and these 2 here, and they're not polarized, those ones. So I think it's just a matter of looking at this and seeing where the parts go. The 82 picofarad, I believe that's them here. Those are 0.1. There should be some other caps in here, I think. Those are resistors. It's interesting that there's a couple of integrated circuits that go into this thing as well. Here would be the here's the 82 picofarad here. So we have all these capacitors and all these components, so let's start mounting. I'll start out by mounting a couple of IC sockets. Now I should point out that this particular headphone amplifier uses 2 vacuum tubes. It does not come with any type of power supply. It needs a plus 15 and a minus 15 supply, as well as a 12 volt supply. It does not come with a suitable power supply, so if you build this kit, you're also going to have to built-in power supply to go with it. Now that won't be an issue as I have access to many power supplies, so I can use a couple of switching power supplies just to give me my plus and minus voltages, and a separate one for the filament voltages. So those are the two IC sockets mounted now, and I guess the next thing I'll mount is I'll mount the binding post for the wires. Got a couple tube sockets we'll mount next. Now, actually I probably should mount the LEDs underneath the tube sockets. They have a couple of little amber LEDs that shine up through the tube socket. I see a little tiny plus there. So this is the longer lead goes where the plus is. Okay, next will be the tube sockets. Okay, those are done. Next we'll put the volume control in. One thing I'm quite curious as to whether these vacuum tubes are actually going to do anything, because after all our voltage is only 30 volts difference. They're 6J5 tubes, two of them. I mean, normally when you think of a vacuum tube amplifier, you think of voltage, right? Higher voltage, but these operate at relatively low voltage, so we'll see. Anyway, let's mount our, I guess we can mount our capacitors now. One's marked 474, go down here. There's two little blue ones here. These ones are not polarized. Actually, I think there's more than two. There's a 474. This one's a 474. 100K. So these are 100K. So we're mounting the resistors now. As I say, everything is well labeled on the board. All of the values here are listed. So instructions really are not necessary for this. I'm measuring all the resistors only because these ones here use multiple. It's not using your standard 3 colors. Like this particular one here, the color is yellow, violet, black, gold, brown. So that'll be 47, or actually it's 47 ohms, right? Because 4-7 with 0 multiplier, but some of them will have 5 bands on it. It's a new way of color coding, where you've got an extra band ahead of the multiplier, because we're down to like the point value. So this would be 47.0 with the multiplier of the gold band. So it'd be 47.0. And there it is, 47.0. So that's going to obviously go in the 47 ohm spot. So we'll mount all those ones. And I'm just using the meter just to verify the resistance. Gone are the days of the old resistors with only the 3 color codes, right? Your 2 digits plus your multiplier. Now we go to 3 digits. So I'm just mounting all the like values of resistors. The resistors are the last thing I have to mount on this, and then I'll mount the tubes and the input-output sockets, which are just 3.5 millimeter plugs. What I'm going to have to do is come up with a power supply for it so I can test it. But we're going to actually put the scope on these tubes and see if the tubes actually do anything or whether they're just lighting up, because it does have a couple of op amps on here, right? So I'm curious to see whether this thing actually does anything, or whether it's just faking it, if you know what I mean. Okay, 47 ohms. 47 ohms are in place. This kit is a piece of cake compared to the ones that have all those little surface mounted chip components. Those were fun to mount. Of course, the color code on these ones would be yellow, violet, black, brown for 4.7470, and then the brown is an extra one for 4700. Now we're down to the last 4.7K resistor, and there is actually one marked 5.1. I have a sneaking suspicion that that goes here. This 5.1 is actually a 4.7 because there is no 5.1 in the kit. So I'm going to mount the 4.7 there. The last resistor is the 1 meg. Okay, last two things to mount. Actually, the IC is going to be plugged into. So there's the unit complete. I just have to get a power supply for it, which I'm going to make one up right now. We're going to hook this thing up. I'm going to plug a source into it, plug some headphones into it, and see how it sounds. Okay, I've got it hooked up to my crude power supply, which is using that voltage to smoke converter power supply that I rebuilt. The one that had the varistor blown on it. While I'm using that as my filament supply, let's turn on the power here and let you guys listen. I'll put the headphones over here. I'm only going to put one channel of the headphones on so you guys can hear it. As it starts up, you'll hear a bit of a hum at first. And then the music should start as the tubes warm up. I may have to, oh, my tape's at the end. We'll try that again. I've been listening to it here for the last several minutes. Okay, I should have some music playing now. Okay, I got some music playing on the DAT machine. I'll put the headphones over the top here so you guys can hear it as it warms up, because it buzzes for a second when it warms up as the tubes warm. And as you can hear, the tubes definitely are doing something, because if I unplug the tubes, you'll hear the sound will cut out until the next song starts here. See if I unplug the tube? As the tube cools off, I've unplugged just the one tube now. The tube filaments are in series. And as the tubes cool off, as this one tube here cools down, it'll fade out. And there it goes. Because the tubes are in series, if I plug the tube back in, as I put the heater back on, okay, as the tube cools off again, takes a while for the tubes to cool down. If I plug it back in, as the filaments heat up, so the tubes are active, they do the job. Basically they're being used as a buffer. The The two chips here are op amps. These are the ones that are actually driving the headphones. The signal path from the input goes in through the volume control. It goes into these tubes, which are just basic triodes. They're running in a low voltage configuration. They're only running about 20 volts from across the plate to the cathode on this thing. I guess, well, I'm running about 24 volts now because I'm running plus and minus 12. It's supposed to run on plus and minus 16. I'm running it on 12 because I haven't bothered to build a proper power supply for it yet. You know what? Doesn't sound bad. Doesn't sound bad. Does it improve the sound? Well, I guess if you like tubes and you like to experiment, this might be a nice little kit. It's not that expensive, relatively easy to put together. Gives you a nice little tube buffer, basically tube buffer preamp. And I'm just feeding it line inputs, and it's driving my headphones quite nicely. It drives them up to an ear-splitting volume if I turn it up, and it's got that tube sound. So, was it a recommended kit? Well, if you like to tinker with electronics and you like to build, it gives you something unique. Remember that you're going to have to supply your own power supply for this. It needs a 12-volt supply to power the filaments, and that 12-volt supply needs about 2 amps of current, and it also needs a split supply plus and minus 15 volts. Again, I'm running it on 12. It seems to work fine on 12. And you're going to have to design and build a case for it as well, because it doesn't come with any materials for a case. It comes just what you saw in the bag there, a bag of parts and a circuit board. But hey, it's a little tube headphone amp. And if you go and buy these things pre-made, you can pay a couple $100 for them. So for what this costs, pretty good little deal. Nice little unit. I'm going to find something to use it for. Obviously a headphone amp, but I like it. Not bad. We'll catch you in the next one. Bye for now.